Okay. So, Mr. Ramadhu, as I told you, today is our day one, and we are going to
Okay.
learn about Cisco CCNP Enterprise. Okay, and
Yes.
this Cisco Enterprise is covering two exams. Okay, okay.
Cool.
One is your CCNP ENCOR and is CCNP ARSI,
Yes.
which is the first one is Cisco Enterprise Network Core Technology, and this one the is the Cisco Enterprise Advanced Routing and Switching. Okay,
Okay.
so this is your. I'll be sharing this one with you, lesson by lesson. Okay, so this one will be your study guide. In that, you will come to know about steps, how to complete those, means the labs you can say. Okay,
Okay.
and the table of content I have already shared with you, right?
Yes, the one that you shared this morning.
Yes, yes. So today we will be starting our chapter first. In that we will be knowing about packet and frame forwarding. And why we are
Okay.
going to know about basics, because see, everything depends on packet flow. So if
Yep.
packet flow is the main part of networking. Okay.
Cool.
So slowly once this packet flow and all these things we will talk today. Okay, and
Okay.
tomorrow we will be talking about VLANs. Okay,
Cool.
let me come again.
Tarla.
Okay, so today we are going to know about our chapter 1, which is packet and frame forwarding. So first of all, when we are talking about network device communication, because when we want to learn about network security or any kind of network communication or any kind of networking, so the network device plays the main role of our day by day work, right? Because when we are in the company, network devices are helping us to communicate. Without networking device, you cannot communicate. Even like I'm not talking. See, network is not only with the two computers, right?
Yes.
Yes. So network means you have multiple computers in your organization, and when you have multiple computers in your organization, right? Okay.
Yes, they have to share them.
Yes. So in that case, you have to you have to know how to configure your networking devices, right?
Yes.
Just give me 1 second. Okay. So network device communication is the main part what we have to learn, or what network administrator or people who work in the network they need to know, because everything is depending on this network communication, right?
Yep.
Yes. So when we are talking about that in network, when you talk about flow of data, okay, so here in the network when we talk about flow
Why
of
that?
data, most of the time it means the communication between applications, right? Right, see, device, when the device is sending data, right? So application is helping you to communicate. Okay, and the
Yes.
application generate data at layer 7, and the device sends the data with the help of OSI reference model, right? You know about the, see, so
Yep.
entire data communication is based on OSI reference model, and OSI reference model is helping you to communicate. Like suppose if I'm sending you email, right? So I'm sending you
Yes.
email with the help of browser. So browser is working on layer 7 with the help of HTTP protocol, right? So
Yes.
when you are sending data, so the data is
Can you
moving.
hear me?
Yeah, yeah.
Okay.
Yes. So your data is moving towards your lower layer, like presentation layer, session layer, like that, right? Transport layer,
Yes.
network layer, like that, and it is moving towards down, and means when you are sending data, right? So at that time your data will be encapsulated, right?
Yes.
Yes. And when the guy to whom you are sending data, when the system will receive that the data, right? So at that time the data will be decapsulated.
Yep. So that he can see it.
Yes, so he can read the data, right? Now, so at layer 3, the device or host decides. Okay, so what he is going to decide? He is going to decide that whether the data needs to be sent to another application on the same device, right? And it would then start move down up
This is on.
the stack of layers. Now what is saying here, that when you will send the data, right, or any
Yes.
kind of information, right? So it may be the data what you are sending, right, whether the data has been sent to same computer, like maybe like you have learned server, right? Do you have idea of server?
Yes.
Okay.
Yep. I have a little bit some knowledge of about
Yes,
it.
so maybe you are using same computer in your organization, okay, and you have opened the same computers. Let me show you here. Maybe this is my server. In this server I'm running one application which is my active
Directory.
directory, right? Okay,
Yes.
so with the help of active directory, if I'm sending some information to maybe my DHCP, to maybe my DNS, or to maybe my IAS applications, okay, so these all applications what we are talking, it they all are installed in the same machine. They all are here, they all are here, and the
Yep.
database is here, right? So when you are using any kind of application, like maybe I'm using one application which is this active directory, okay, and with the help of this active directory I'm sending some information, but this that information is moving from your active directory database and is looking for DHCP, right?
Yes.
Okay, or maybe it's moving from your active directory and looking for DNS, or maybe it's moving from your means. So what here is
Yes.
saying that whenever you are sending some data, and maybe that data, right, maybe the application what you are using, maybe it is on the same device, right? So it doesn't mean that it will follow the same process of OSI reference model. Are you understanding?
Yes.
Yes. So your system will, or your data will follow the OSI reference model when your data is moving from your computer and going to another computer, right?
Yep.
Yes. See here, the data needs to be sent to a different device, right?
The
Then
device.
it
Yep.
will process the OSI reference model.
Okay.
Okay, so it doesn't mean that you are using same computer and you in the same computer you are using different type of application. So if you are sending data from one application to another application, so it doesn't mean that it will follow the OSI reference
The
process.
second place.
Yes, it will follow some kind of process, but it will not follow the your OSI reference process, right?
Okay.
Okay, so you already know that the data sending and receiving will be completed once the complete layer 7 process will be uh, optimized, right?
Yep.
Yes, and the data first, when you are sending data, it will be encapsulated, and when the client will receive the data, or when another computer will receive the data, it will be
Encapsulated.
decapsulated. Yes. Now here we are talking about layer 2 forwarding. Okay, so when we are talking about layer 2 forwarding, so each layer 2 technology use a different addressing mechanism for data communication. So in our network, see, when you will work as a network engineer, so most of the problems in the networks is related to layer 2.
Yeah. Switch.
Yes, yes, switching is the main problem. Okay,
Okay.
Yes, routing, see, routing will have some difficulties and problems, but switching will create lots of problem. Okay, so
Okay. Yes.
yes, so each layer 2 technology use different addressing mechanism. So here is saying that, for example, Ethernet use MAC address. So in our organization we use Ethernet, right?
Yes. Yes.
Yes. So if you will talk about any organization, they use Ethernet, right? And Ethernet use what? MAC address, right?
MAC addresses.
Yes. And there were some other old technologies like what you can say, frame relay, but frame relay is not in use.
Okay. Nowadays.
Yes, nowadays relay is not in use. But when we were using frame relay was also layer 2 technology, and frame relay was using DLCI.
Okay.
Okay, data link connection identifier was the DLC. There was some number we were using that time. Okay, but now we were not using frame relay, and who replaced the frame relay? MPLS.
Yes.
So MPLS removed the frame relay, and how MPLS is working? MPLS is working on the basis of labels.
Labels.
Yes. Okay. Now, so in this CCNP entire course, we will be working on Ethernet and
Wireless technology.
yes, wireless technologies. Okay, and Ethernet and wireless technology, they both use
MAC address.
yes MAC addresses. Okay. Now if I'm talking about MAC address, so MAC address is of 48 bits, right? And it is
Yes.
divided into two part.
Two parts.
Okay, the first part is known as organizational unique identifier. So if I'm talking about, if you'll come here, so if we are coming here to our this computer, and if we are coming to check our IP config. Okay, okay, so IP config slash all.
All in
Okay, IP
space.
config space forward slash all. See here, this is simulation, right?
Yes.
Okay, so here this command is asking a space, right?
Yes.
But
Yes.
if you will come to real computer,
Mhm.
and if you are typing here IP config no space and type like this, it will work.
Okay. I see
Okay.
the difference.
See, it's working your MAC address.
So here, if you introduce if you put the space, it will not work in
Where
the real
in the
device.
simulation, this is packet tracer. It will
In the simulation, is working. If you do the same one, this one, if you do it in the real device, is it
no,
going to work?
the both will work. The same will work.
Okay. Okay.
Both is working.
Okay.
Okay, so this is our MAC address, right?
Yes.
So let's copy this one, and if you will come here to MAC address vendor lookup. So if you'll come here, MAC address vendor lookup, and if you'll type like this, the MAC address what we have copied, and press enter here, they will tell you that okay, this MAC address is of
Cisco system.
Cisco systems, right? So if you want to know that okay, the MAC address what we were talking here, this MAC address is related to which type of devices. So here with
Okay.
this, only this two, okay, only this half part, because see,
Okay.
a MAC address is based on it is made of 48 bits. So when you have 24 bit, is it is used for
Six.
vendor specification. Okay,
Okay.
and this 24 bit, if you'll copy only this 24 bit only, and if you'll come here, they will let you know that okay, it is of Cisco systems. Okay, see, Cisco systems. Okay,
Yes.
and if I'm okay, so it's showing Cisco systems, right? No problem. Let come here, open cmd IP config space forward slash all. or it's simple what you type. One other command is also there, get mac. Okay, get mac.
Okay.
Okay, so maybe I got lots of mac address here, so let me copy this one, the first one, copy. And if you'll come here to your paste, enter. See, are you understanding?
Yeah. Intel Corporation.
Yes. So it is of Intel Corporation. Okay. So what is saying that the MAC address is of 48 bits, and the MAC address is divided into two part. One, the first part is known as organizational unique identifier. In that you will come to know that okay, this MAC address is of Cisco systems or Juniper systems or Microtech. Okay. And other
Wow.
24 bit. Okay. That, who decide that one? Okay, that is decided by the, like for, like, suppose Cisco systems wants to create something, MAC address, right? So he's not going to
Yes.
create. MAC address is what? MAC address is a number, but the MAC address will be entered in the RJ45 port, right? The
Yes.
NIC card. Okay, so the other 24 bit they used to keep for you, what you can say, for those card identification. Okay, so this is the card number 1, this is card number 2, card number 3, card number 4, like that. Okay, let me see, this is not important, but let me explain you the, this is, suppose I have one LAN card, suppose this is my LAN card. Okay, this LAN card is of Cisco systems. Okay, and this LAN card is of 48 bit, so 24 bit and 24 bit. So 24 bit is of organizational unique
OUI.
identification. Okay, and 24 is for vendor. Okay, means device ID, device ID. Okay, now suppose this LAN card number is 1111000000 something C, something like that. Okay, so
Okay.
maybe some hacking has been done by this LAN card, because see, when you want to do some kind of any kind of network sniffing or something, you need to be connected to the internet, right?
Yes.
Yes. So when you will do something, so this MAC address will be used, right,
Yep.
with your IP
I
address.
see. Mm.
So when this MAC address will be used by the IP address, so when the forensic expert or when any kind of network monitoring will run, so how they will come to know that okay, this computer has came there. So first of all, they will come to know Cisco, then they will reach Cisco. Okay, forensic
Okay.
experts, they will go to Cisco, and then they will say, okay, please, can you tell me this MAC address? Because they, how they came to know about Cisco, because of this 24 bit.
Yeah.
Okay, this 24 bit, then they will, then Cisco will check about this 24 bit. Okay, that this LAN card I have given, means I have connected to which systems, whether it was Cisco switch, whether it was Cisco router. Are you understanding?
Yes. I
Then they
see.
will say, okay, so this Cisco switch, then okay, they will say, okay, this Cisco switch I have sold to whom. Are you understanding? Or this Cisco router I have sold to whom? Then they will come, okay, I have sold to so and so person. Then the forensic expert or maybe the government will reach to this guy. Okay. So that's
Yes.
why they are using these kinds of algorithm. Okay. Now,
Okay.
so when we are talking about these all communications and these all, right? So there was some other communication, and the communication started, or centralized communication started with the help of hub, right? Because when we are talking about these all devices, something like that, see, when I hope when you have started networking to learn network, what are types of
Yeah.
networks.
I've
Okay,
seen this
yes,
kind of.
yes. So at that time, uh, in the initial time, we had only like computers, right? So computers
Yes.
and computers were communicating. Now we wanted to have more computer to be connected in our network. Then we said, okay, let's have centralized device. So hub was the what you can say, the first centralized device, okay,
Yeah.
which was introduced, and we were using it, okay. And hub was supporting the speed of 10 mbps, and that 10 mbps was also enough at that time when the network started.
Yes.
Today we can say, okay, the 10 mbps is nothing.
It's not enough.
Yes, but when the network started at that time, 10 mbps was also a huge speed, you can say. Now, so here we have to know about what is collision domain and broadcast domain. See, when we are learning something like CCNP, so we are not going, like each and everything. We will just go in overview. So if you know, then it's okay. If you don't know, then we will be working on that, right?
Yeah, I understand. Yep.
Yes. So collision domain. So what is collision domain and what is broadcast domain? So in working on that collision domain, first we have to learn and to see some practicals. So let's come to the practical. Okay, so let's see how we are going to know about collision domain. Suppose this is my computer A, okay, and these computers are connected with the help of hub here.
Oh,
This is our hub, okay, and this is our switch, okay. Now, okay. So whenever any computer in the system and in the network, when they wanted to communicate with the help of hub, see what is happening.
okay.
If computer A wants to communicate to computer D, okay. So see, the first packet is what? It's a ICMP packet, right? So computer A
Yes.
wanted to communicate to computer D with the help of ICMP packet, okay. So instead of sending ICMP packet, the computer A is first sending which packet? ARP packet.
R. Yeah.
Yeah, R packet. Why? Because if you'll see in this ICMP packet, if you'll click here in the ICMP packet, okay, now see, if I'll come here to the outbound PDU details, it's saying that I have source IP address, right? Okay,
Yeah.
I know destination IP address. Of course, when you will ping to someone, when you are pinging, you know the destination IP, right? Okay,
Yes.
yes. And this packet is what? ICMP packet. Are you understanding?
Yeah,
Okay,
I can see.
yes. So this packet is ICMP packet, and in ICMP packet is what? Is it's used for communication purpose, right? Okay,
Yes.
yes. And it is layer 3 packet,
Okay.
okay. And now see, and when you will click here in the ARP, why they are looking for ARP, if you will come here to the ARP, is saying that I source IP address is this, okay, and source MAC address is here, right?
Yes.
Okay, this is ARP packet. If you'll see here, it's written ARP, okay.
Mm.
And he's saying that my target IP is this one, destination IP. I know destination IP, but I do not know destination MAC address. Okay. So if you are using any type of communication, even older time or today's also, whenever any PC wants to communicate from source to destination, the computer need both, okay, layer 2
The
address
address.
as well as layer 3 address.
Okay.
Okay, so if you have layer 3, so it doesn't mean that you will directly communicate to the destination system, okay. So if you do not have MAC address, so your system will generate ARP message, okay, and he will broadcast, your system will broadcast for looking the MAC address of the destination system,
Yes.
okay. And your system will broadcast to FFFF. Why broadcast? Because that is the broadcast MAC address. Are you understanding?
Okay.
Okay.
Yes.
And then he will give to Ethernet, because we are using Ethernet technology, right? And now you can
Yes.
see here. And now if you are coming to OSI reference model, okay, see, okay, now it's layer 2, right? So he's
Yes.
saying that layer 2 Ethernet header is saying that this is the MAC address, source MAC address, the destination MAC address is not there. That's why ARP packet has been broadcasted here. Okay, source
Okay.
layer 3 IP, so destination layer 3 IP. And
Yeah.
now if you'll close this one and then you click next. Now see, it reached to hub, and then what hub is doing. Hub is,
Sending to all the.
yes, sending to all the machines or all the devices which is connected to hub. And
Yeah.
why the hub is doing like that? Okay, now why hub is doing like that? Because see, collision domain means, first you have to understand the collision domain. Okay, collision domain and broadcast domain example. Then we suppose, you know, the racing track,
What?
car racing track.
Okay.
Let me show you. Car racing track. Okay, see,
Mm-hmm.
car racing track, or what you can say, which one? Racing track. Let me show. Mm, I'm not getting exact example. Okay, if you are coming to this car racing track, see, if I'm
Okay.
talking about this car racing track, so can you see here, the each and every car have separate path to run, right?
Yes.
Okay, means this is the single for different one, this is for different one, this is for different one,
Mm.
right?
Yeah.
Okay,
Yeah.
so this is known as collision. Means
Okay.
how many collision you can say here? One collision, two collision, three collision. Means, you know, like 4 lane, 5 lane, 6 lane. So that those
Yeah.
lanes are known as collision. So if you will
Oh.
come, if I'm communicating, if I'm using this lane, and if any other data will come, then the data will
Yeah.
crash.
There'll be,
That's why
yeah,
it is
there'll be
known as,
collision.
yeah, the data has collide, accident.
Yeah.
Okay,
Okay.
you know, when people run also, what uh, we use that marathon something like, I don't know. Let me find the correct one. Okay, let me show you.
Okay.
Okay, so you can see here, see, when we are talking about human racing track, so see the track number 1, track number 2, track 3, 4, 5, you will find the tracks like this, right? And see,
Yes.
if
Yes.
people are racing, right, so each and every people has a different uh, racing track, right? Or you can
Yes.
say line or path, you can say,
Yes.
right?
Yes.
Yes, but here, so what is saying here, so here people can use their own path and they can communicate, there will be no accident.
Yeah.
Okay, but in hub, see, in hub what is happening, if this hub is of 10 mbps, okay, if this hub is of 10 mbps, so each and every port which is connected to this hub, they will be sharing the bandwidth. Okay, it's not that each and every pc will have 10 mbps, it will be
Yes.
divided by,
By the number of
yes,
device.
the number of ports which is connected. So if right now,
Yes.
if four ports are four systems are connected, means the PCs will, they will get around 0.25 mbps, right? Or no,
Yes.
sorry, 2.5 mbps.
2.5.
Yes, mbps. But if like if 10 computer, if right I am using 10 mbps, if the speed is 10 mbps, and if 10 computers are connected to this hub, so the speed will be divided to those 10 computers, and each people can use only 10 mbps. Are you understanding?
Yeah, I understand.
Yes. And see why I'm explaining hub. We are not using hub, but why I'm explaining hub to,
Yeah.
yeah. So I'm explaining the demerits of hub.
Okay.
So when I will explain you demerits of hub, then you will understand the benefits of switch.
Oh, I see.
Okay. Yes. So here now these what we were talking is 10 mbps. Yeah. Okay. Now,
Mm.
and in hub, what is the other problem? Hub do not have memory to store the information, right? You also know this one.
Okay.
Now see here
Yes.
what we were talking, that hub has broadcasted. Okay. And it has broadcasted the information. And now see, when I'm clicking next, so this PC is saying that yes, I have received the data. Now when this PC has
Mm-hmm.
sent the data back to hub, again see this. So normally the packet should come to PCA, right?
Yes.
Now see what hub is doing. Hub is also broadcasting. And
To
now,
others again.
yes, and now if you'll see this packet, so this packet is what? Now ICMP packet. Now it's not
Okay.
R packet. Okay. Why it's not R packet? Because see, ARP has gone first. Okay. And ARP came. Okay. See here. If I'm
With the
coming
MAC
here, let me
addresses.
open this one. See. See. Now your ARP has given the MAC address of that system. So if I'm coming to OSI reference model, see previous, next, next. Okay. See, the ARP process out this packet from the buffer and respond it, and the device encapsulates the PDU, protocol data unit, into an Ethernet frame. Okay. So what it's saying here, so the data has gone, so ARP has gone to the hub, and then ARP came to PC. Okay. And then
Yes.
PC came with the IP address to this computer, and now they are communicating. That's why whenever you will try to communicate to any computers in the network, right? So first packet, whenever you are sending, maybe you are sending 5 packet. Remember in our CCNA lab also, so the first packet always get dropped, right?
Yes.
Yes. Why? Because the first packet is always ARP packet, whether
Yeah.
it's layer 2 communication or whether it's layer 3 communication. Because see, for layer 3 communication also you need MAC address.
First of
That's
all.
why the first packet will be dropped, and then other packets will start communicating. Okay.
Okay.
So now again see, if you are again communicating, so again it should come like this, and now see again it is broadcasting. Okay. And now see
Except the
why
property.
this time when this see, let me close this one. Okay, let me take another packet. If this time this PC is trying to communicate, right? Okay.
Okay.
So in this time, this packet is what? ICMP packet. So when it will
Yes.
go to hub, right? So why this time this PC hasn't generated R packet? It's directly generated ICMP packet,
It,
and then ICMP
it
packet
knows
reached to, yeah.
it knows already the MAC address.
Who knows?
This I'm talking about the hub.
No, but see, who generated? Let me come back. See, this PC is this PC, right? See, this
Yes.
PC is generating what? ICMP packet,
ICMP.
but initial before this one, this PC has generated ICMP, but he kept hold that ICMP packet, and he sent
Okay.
first R packet. Okay, but now when I started second communication, then he generated ICMP, and but no
Okay.
R.
Oh yes, I see.
See, so why? Because if you'll come to this PC, if you'll come to command prompt, and if you'll type this command, a arp minus a, see, this is what, this IP is, whose IP is this
IP.
one? I'm on PCA.
PCA, yep.
Yes. So now PCA know about PC4.
I see.
Okay. That's why PC is generating what? PC is now generating unicast packet. Are you understanding? Because PC know about, see, PC know about layer 3 address as well as layer 2 address
Yeah.
of destination computer. But when the data is coming to hub do not know about anyone, whether hub do not know about layer 3 packet, hub do not know about
Yep.
layer 2 packets. That's why hub is saying, my friend, I don't know anyone, let me broadcast it. Again he is broadcasting. Are you
So
understanding?
anything that is see, he has to broadcast it.
Yes. So these two computers saying that no, it's not my data, the data. So this computer accepted the data, and now this computer is replying. Again the reply packet will go to hub, then again hub will say that, my friend, I don't know. So see, for this small network, the hub is doing these kinds of silly things, right? But if it is a
Yes.
large network, are you understanding? If it
It's
is a
gonna be a
large
big
network,
problem.
in that network what will happen, your hub will,
Crash.
yes, crash, and hub will become slow. And why it is? Because see, now you there is one thing in the hub, that hub, let's come here, see, let's know about, see what is saying here, the problem. Now understand this. See, the problem with the traditional networks, okay, using hub, and you have understood about the problem. Now let's know more about this. uh,
Okay.
these were devices operating on half duplex mode, creating only a single collision domain. And what is half duplex mode means? Only one computer can communicate at same time. Okay, only one computer can communicate at the same time, means yes, second computer can also communicate. If you am talk, if you are saying here, let me come here, let's take one packet, send from here to here, let's take another packet, send from here to here. Okay, but and if you will now start this process, now see, packet came. Okay, see, can you see the second packet? Now second packet
Yeah.
is moving. Are you understanding? So
Yes.
yes, now see, have you seen it's crashed, right?
Yes.
Okay.
So this is the collision.
Yes, and if you'll read this collision, okay, maybe this see, you will not get more details here. Okay, maybe related to some code, some information is there, but in graphics you can see here, right?
Okay. I can see
Yes,
it.
yes. So what is saying here? If someone will leave the track, and if someone will move to another track, and the track is already busy with the data, it will crash.
Yes.
Okay, and it is why it is crashing, because they use only single collision
One.
domain. Okay, means single collision domain means simply you say that, road with single car, so only single car can go. But if you will say that
Yeah.
multiple car will come, okay, so it will, means there
There
will
will
be
be an
accident.
accident.
Yes. And some roads, if you'll see some roads in Dubai or somewhere, you'll find, like six car can go at the same time.
Yes.
Okay, so those are known as multiple collision domains. Okay, now collision domain is what? A group of ports, you can see here, a group of ports which share the same bandwidth. Means if I have 10 ports in on my, what you can say, on my, to my hub. Okay, so if you have 10 ports on your hub, means that speed what your hub is supporting, that will be divided into 10.
The number of ports that
The number of ports what you have, the number of ports what
connected.
you are using, it's not that what I
Yes.
have. Are you understanding?
Okay. Yeah.
Yes. Okay, now come here. Now only one device could send or receive data at the time, other needed to be wait for the previous communication to be over.
Okay.
Okay, but my friend, we are human, right? We can
Yes.
understand that okay, there is traffic, there is some car is going on, right? But how data will
Yeah.
know? Okay,
At all.
yes. So there was some technology, and still this technology in use. Okay, CSMA CD, carrier sense multiple access collision detection. Okay, now if two devices start sending data
At the
at the
same.
same time, collision occur in the network and bandwidth will be wasted because the data will collapse, right? Now
Yeah.
there was some kind of technology used in the hub, that is known as CSMS/CD. Okay,
To
now
avoid this kind of problem.
come again.
To avoid this kind of problem.
Yes, to avoid this kind of collision problem, because see here the data has collide, right? Let me run the data
Yes.
again. One data here and another data from here to here. See, they are communicating. The communication is separate. See, computer A is trying to
Yes.
communicate to computer 4, and computer B is trying to communicate to computer 3.
See.
Now if the communication will start, see, is gone there. Now see, have you seen the data has collided?
Yeah.
Okay,
Yeah. Yes. Right.
okay, now let me show you from here. Okay, now let's see, data came here and it's, if you'll see the, see, data has
Yep.
collided. Okay,
Yep.
so here is saying that, okay, now, so if you want to like to stop the collision, okay, there was some technology which was used, that is known as CSMS/CD. So CSMS/CD process use back of timer algorithm, okay, was used to come out of the collision, means it was helping the data. So first what he will do, he will work like a traffic police. He will say, there
Okay.
is some data is, means this path is busy. So what he will do, the second packet, he will tell that second packet that no, please wait, just for nanosecond. It's not that for 1 second, 2 second, 5 seconds, are you saying? Just
Okay.
nanosecond, because see, data is very fast, so nanosecond is also difference is there, so there will be no collision. Okay, so this CSMS CD was helping the second data to reduce his communication time just with nanoseconds with the help of back of timer algorithm. Okay, now, so other problem, as more devices are added to the cable, okay, the less efficient your networks will become, because see, if the your hub is 10 Mbps, right, and if you will add uh, maybe like 20 computers, right, or 50 computers, so your
You
network
divide
will
it.
become slow, collision will there, right, and your network means what is saying that at older times, when we were having a small network, at that time hub was okay for us. But now when we have a new technology and we have a good speed and we have a large network, in this condition hub is not correct. Okay, now,
Yes.
and why I told you why hub was always broadcasting, because hub do not have any kind of intelligence, means there is no any kind of memory stored in the hub. Okay, that's why when the any data is coming to hub, it is directly forwarding those data to every ports which is connected to the net, to the hub, right, except the receiving port, right?
The sending port.
No, sorry, yeah, what you can say, sending port, like see, if this computer is sending data, okay, so this hub will broadcast the data except the receiving port.
Yes. Yes. I see.
Okay, okay, and this function, this broadcasting function will be repeated every time. It's not that okay, one time I have I have broadcasted, because first time I was not knowing about the destination address. That's why I broadcasted. But this broadcasting is for, for a long, because hub don't know anything. Even if the data is passing from a hub, and when the data is coming back to hub, he will say, no, I don't know anyone. I have to, because
Same
my
thing.
behavior is to broadcast.
Yes.
Okay. Okay. So to overcome from this problem, we came with switch.
Switch.
Yeah. So what is switch? Now understand about switch. Okay. So what switch is saying? Now understand about switch. So a network switch solve the problems. Okay. How? By creating with the MAC address table. Okay. Now why he is creating MAC address table? Because the switch have storage, the data storing capacity, or you can say the MAC address storing capacity with the help of flash memory. Okay.
Okay.
Yes. So switched network operate at full deplox mode, which result in one collision
One
domain
condition.
per switch port. Means it is working in full duplex. Okay, but
Okay.
hub works on half duplex, and it's saying that switch also work in collision domain, but switches have multiple collision domain, and depending on its ports. So if
Yes. Number
switch
of
have 24 ports, means switch can work on
24 collision.
24 collision. Now tell me, I have one example here. uh, okay, see this track. Okay, so you can see here how it maybe just take count the track. 1 2 3 4 5 6, few tracks are free, right?
Yes.
Okay, now, so when these people are running, so just take example of switch. So switch has all these ports. Okay, now 3 ports or 4 ports are not in use, right? So if somebody will ask you that, okay, switch have how many collision domain, so you have to say can switch can use 24 collision domains. Okay,
Yes.
but switch can only use running collision domains. Means if how many collision domains are in use. Are you understanding?
Yes, I understand.
Yes, switch can support 24 collision domain, but right now switch is only using 6 collision domain. Okay, and that's why when switch will try to communicate, see. Okay, so here if switch is also trying to communicate from here to here. Okay, so now see, this PC has generated one ICMP packet and one
Yes.
R packet. ICMP packet is on hold. Why? Because PC do not have MAC address of this
Not
destination
address of.
computer. See, right now PC have MAC address of, see, right now if you'll come here, let me take the example of one computer. Okay, this is your PC1, and this is your PC2. So when this PC is trying to communicate, okay, so he will generate one packet which is known as ICMP, right? But ICMP is on hold. Why? Because ARP is created. And
Generated.
why ICMP hold and why ARP is there? ARP packet has been generated because see, source IP, when you are sending any data, so okay, so there will be source IP. So source IP is 10.0.0.1. Okay, source MAC, of course there will be, because if I am sending data, so of course I am source, so I know my source MAC, right? So my source MAC is,
Yes.
suppose 0A, something like that. Destination IP, yes, I know destination IP, that's why. Okay, so when you don't know about destination MAC, okay, if you don't know, okay, at that time this ARP message will be, ARP packet will be generated by the computer who is trying to communicate, or who has generated this, what you can say,
Okay.
ICMP packet for communication. Okay, and now if you are coming here, now see the communication, see the communication came here to switch. Okay, and now switch has broadcasted. Why? First time switch will broadcast this, you know, this switch behavior, right? But if the communication is coming back to switch, now see, the communication is unicast,
Yeah.
right?
Goes
Yes, communication is
goes
unicast.
straight to the sender.
Yes, and if you'll come to this switch and to check, okay, so MAC address table, see, now you can see here, this is the first one. Okay, but so right now your switch have only two MAC address table, the PCA MAC address table and PC4 MAC address table. Okay, are you
Okay.
understanding?
Yeah, I see.
Yes, but what is the MAC address? How switch is creating the MAC address? Because see, when this PC, see, this PC has created ICMP and R packet. Why? Because this PC was not having the destination MAC address, right?
Yes.
So okay, see here, when the packet has reached to switch, okay, so immediately switch will create MAC address for whom? Tell me.
For the sender.
Yes, for PCA, right?
PCA, yep.
Yes, and now the data has, now tell me, do switch will do anything in this case?
Mm, not yet.
Not very good. Okay, now in this case, do switch will do anything?
Yes, he has to send the MAC address of
Not send.
10.
Switch will
Save
store
it.
the MAC address of PC
4.
4. Yes. Okay, and then once he will store the MAC address, okay,
Yes.
now see, still our packet is there. Are you understanding? Can you see?
Yes.
And now see here, still our packet is there. Okay,
Okay.
if you will click here, okay, still our packet is there, but once this packet will be received by switch, okay, now
Yep.
what switch will do? See this, the switch will change that packet. Mhm. Okay, and then it will change that packet to ICMP.
ICMP.
Yes, because see, actually that packet was for source, that packet was, first packet was ARP, but the second packet
Yes.
will be ping always ICMP. Now see, now when you are sending second packet is always ICMP.
Yes. There's no R.
Yes, no ARP. Okay, and now see, let me show you one thing. If you are generating another packet for PC from here to here, okay,
From 3 to 1
1
from
to
1
3,
to. Okay.
okay, now see, ICMP packet is on hold and ARP has been generated. Why? Because this PC do not know about the destination,
3.
that's why ARP packet has been generated. And now see, okay, let, now see, it will come here, okay, and then it will broadcast again,
Okay.
and who will reply? And why is
3.
broadcasting? Because this PC was not knowing about the destination MAC address. So whenever any packet, it's not PC, it's not switch, okay,
Yes.
when packet do not know about destination MAC address, okay, and when the packet will reach to the switch, okay, And switch, okay, now tell me, do switch know about PC3 MAC address?
Not yet.
No, that's why switch has broadcasted it. Now you will
Yeah.
ask one question here, okay, that, okay, it was,
But he knows already about the 4-1.
yes, good, 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 good. I was expecting this question. Okay, now you are saying that why switch has see, packet came from here to here, right?
Yes.
Okay, switch know about that, okay, who is connected on this port, right? On fast ethernet
Yes.
here, and switch know also that who is connected here. So
Yes.
if switch is broadcasting only on this two port, then I can understand, right?
Yes.
But why switch is broadcasting on each and every port except the receiving port, right?
Yes.
Yes, now see what is the problem. See, switch do not know about the MAC address, right?
Yes.
Okay, now did you told to the switch that the PC, okay, no, 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 I'm very fast now. Okay, suppose this is switch, right? Okay, maybe switch is saying that maybe someone is connected like this. Okay, switch is thinking maybe the destination what you are looking for, maybe he is connected after this port. Are you understanding?
Okay. Okay, I see.
Because yes, because some you will find somewhere, so normally what switch is thinking that maybe the computer what you are looking for, maybe that computer will connected here. Are you
They are
understanding?
behind. They are behind the number 4.
Yes, behind the, means like maybe I'm connected with another switch and maybe that computer will be after that switch. Because see,
Yes.
on this port, on this port, did you told that to the switch that is it a,
Anyways.
yeah, do you know about port fast, BPDU, some guard or something like that? Remember?
Yeah, I remember. I remember.
Uh,
It. So I did not go deeper.
access port,
But
trunk port, like that.
yeah,
So
yes.
if you will tell this that no, 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 you are only access, or you can only store single MAC address on this port, right? So if
Yes.
you will tell these things to the switch, then switch will not broadcast here, because if switch knows that okay, someone is already connected.
Yeah.
But right now switch has only single default capabilities, that is storing MAC address. You have not configured anything. That's why switch is running with his default behavior.
Okay.
Okay. Now, okay. Now it means, as I told you that it is it has multiple collision domain. So here is saying that okay, it means that more than one device connect to each port and send the data, and sending and receiving of the data will be simultaneous. Now let's see, if I'm coming to switch, let me close this one. Okay, now let's see whether the communication is simultaneous or the data is crashing. Is it okay or we need more packet?
Yeah, even 3 messages.
It's okay now, right? Okay, now
Okay.
start the packet. No crashing.
Just some pause and then.
No, I'm running one by one. That's why it is coming like that.
Okay.
Okay, I am just pausing, but see, there is no crash. Okay,
Okay.
if you will run like this, see, it's running faster. Okay,
Yes.
okay. So now, okay, now, so instead of flooding all traffic out of every switch port, a switch use local MAC address table to forward the network traffic only to the destination port which is associated to it, right? And why
Yes.
it is doing like this? Because once each and every port, now see, if I'm coming to this switch, now see, according to this communication, if I'm coming to this switch, okay, see, now switch know about everyone, right?
Yes.
Okay, so now the communication will be unicast or broadcast?
Unicast.
Unicast. See, only single packet has been generated. And now see, next, see, it's unicast. Okay,
Yes.
okay,
So no more ARP.
no ARP. Okay, and one more thing, this ARP, okay, switch can only store the MAC address information for how long? For 300 seconds. Okay, switch,
Okay.
switch. Okay, and PC will keep the MAC address table or ARP table, not MAC address table, ARP table. Okay, for how many? 4 hours. Okay,
4 hours.
yes. So PC keep the information of what you can say, the PC maintains the ARP table for 4 hours. Okay, and if there is no communication from for that same destination for last 4 hours, then PC will remove the information. Okay,
Okay.
and
Same like
switch,
for the switch. After 6 seconds,
no, three,
if
no,
there's no
five
activity,
5 minutes, you can say 5 minutes.
yeah, 5 minutes. So after, if there's no activities, it
Yes,
would delete.
yes, it will delete the information from the switching
The
table, or
Mac
you can
table.
say MAC table. Okay,
Okay.
okay, so you can see here, you can see here, see, this is your switch, right?
Yes.
Okay, and what is saying that one collision per domain. Okay, we'll come to know about
Per
broadcast
port.
domain also. Yeah, one collision domain per port means, here is saying that, see, it means one path. Okay,
Okay.
here also single path. Okay, that's why there was no accident. Okay,
Yes.
single path. Okay, and each and every computer is free to communicate. That's why switch is full duplex.
Okay.
Okay, now let's talk about broadcast. What is broadcasting? See, it is a group of ports. Okay, he's saying that it is a group of ports. Okay, or device which receive the same message or information at the same time. Okay, now let's see how this what you can say, broadcasting is working. See, broadcast domain concept. Now, if all the computers, okay, they are connected with switch, right? See, earlier we have seen that if this computer is sending data, right? So if it is a single switch, right? So
Yes.
you will not understand broadcast, but when you have multiple switches in your organization, so if
No.
this PC is communicating to this PC, right? So
Yes.
normally what could happen, that the data should come here to switch, and the data should come directly to PC3, right? Normally, right?
Yes.
But see what is happening here. Data will come to switch. Switch do not know. Switch will broadcast. So the data will forwarded to this computer, and then sorry, this switch, and then this switch will broadcast. So the data will be broadcasted to each and every switch of your network. It's not
Okay.
only that it will be limited to the switch which is connected to that computer. Even suppose, maybe for example, if I'm taking, like, let me take like this. Okay, let me take one switch here. See, the switch behavior, right? It goes for listening, learning, and then it will go for forwarding, right? See, port, this is the
Yes.
port behavior, switch port behavior. So when you will connect with switch, then switch will go for first listening, learning, then forwarding.
Yes.
And it takes
Yep.
50 seconds. Okay,
Okay.
15 second for listening, 15 seconds for uh, no, listening 15, learning 15, and 20 is for forwarding.
Okay.
That's why we have to wait for 50 seconds.
Cross up.
Okay, meanwhile, what we can do, we can come to these computers. Let's assign IP address 10.0.0.7. Close this. Now let's come here, 10.0.0.8. Okay, now let me generate the new packet, right? If
Okay.
this PC wants to communicate to this PC in the same network and in the same switch. So now see behavior. Came here, broadcasted. See, again broadcasted. See, this switch will also broadcast. So see, for a single communication, okay, see how long the broadcasting has been deployed. Okay, that's why company is saying that, okay, okay, if I'm using, maybe I have something like this. Okay, uh, maybe I have a branch, right? Okay, let me copy this. Okay, so if I'm using some branch kind of thing, or department, you can say this is another department. Okay, this is another department. Okay, and this is another department. So when this computer is trying to communicate, if this computer is trying to communicate to this one, but you are disturbing to entire department people, right?
Yes.
Okay, that's why, now tell me what is the solution.
The solution is VLAN.